Welcome back to the next example, example 2.11, where we have a 380 volts three-phase delta connected induction motor. It is delta connected induction motor, so that means the load is connected in delta fashion, all right? And it has an output of 18.04 kilowatts. That means it has the output. Let's say the output is taken as like this. Let's say it is the output. Let's say this is the input to make things easier for us. So the output is having, that is on the output side, it measures 18.04 kilowatts. That means you don't know what is input into the motor, but we are given the efficiency of the motor, and you say you calculate the readings of each of these wattmeter connected in lines A and C. That means it is having 2 wattmeter on lines A and C. So this is WA, this is WC. So this is the input to the motor, this is the output. So the output is 18.04 kilowatts. So we want to know what is the input. The total input will be the combination of these. And of course, we are given the efficiency, which can help us to know what the input is, because we realize that the efficiency is equal to the output power over the input power. And what is the output power? The output power is 18.04. The input we don't know. And the efficiency itself is given as what? 82%, which is 0.82. So we can then find our P in, which gives us 22 kilowatts. Right. So that means we have our P in, which is the input power to this, which means our WA plus WC is 22 kilowatts. Right. Then which formula are we going to use? It will be determined by the direction of rotation, which is given as what? It's positive phase sequence, and that is positive. Then we know they are on 2 lines A and C. So with that one, we can now agree that our tan phi, the formula that we use will be √3 WC minus WA over WA plus WC. So that's the formula that we use. So we need to find the phi, and what is the power factor given to us? Our power factor is cos phi, which is power factor is 0.82. 0.82, right? So lagging. So we can find our phi to be at 34.92 degrees, which we now substitute here. 34.92 degrees is equal to WC minus WA over WA plus WC, which is 22 kilowatts. So when you find that out, you find that your WC minus WA, after you have done your calculation, you find that your WC minus WA will give you what? 8.867. So, which can be equation 2, while this one is taken as equation 1. So you can add equation 1 and 2 together, whereby you now have 2WC to be equal to, you add this together, that will be 30.867. And you can now find your WC. Your WC will then give you what? 15.433. kilowatts. So that is your WC. So you can then substitute WC into any of the equations, then you find your WA. That sorts that one out. Thank you.